everybody. It's so great to be here. And without any further ado, I want to introduce our panelists and get right into it. We have Allan Steinhardt. Now, both of these guys have a million different ways of being identified. We're going to go with one, but I want to explore what they do. Allan Steinhardt, who is the chief engineer at AEye. That's AEye, AEye. And Greg Charvat, who is the CTO of Humatics Corporation. Welcome, guys.
Thank you very much.
Is this on? Yeah, it is.
Oh, heck, I broke it already. We haven't even gotten started. So you guys, we just saw a really cool demo of what you can do with just cameras. We're here to talk about the entire smorgasbord of tools available to us in the self-driving space. And I want to start with LiDAR. As a tech journalist, I write about the massive controversy with LiDAR, and by massive, I'll define it as this. Elon Musk does not believe that LiDAR is necessary for self-driving cars, and everybody else I seem to cover seems to think it's a must-have. But still, it's a controversy because as far as I can figure as a tech journalist, Elon Musk may contain the body of Jesus somewhere inside. So let's start with that. What's the role that LiDAR has to play in self-driving technology? Greg, I'll start with you.
Okay. I would say that self-driving automobiles must be extremely reliable, okay? And Allan alluded to that, and we had a little email conversation about this. And, you know, this is a life or death technology. People will get killed. They already have been killed. There's that fellow who was watching Harry Potter with one of Elon Musk's vehicles who slammed into a truck. These need to be very, very reliable systems. Therefore, they need more than just optical sensor platforms. They need optics. They need LiDAR, they need radar, and they also need high-precision radio navigation. We're talking more precise than differential GPS. They need all four of those things to perform their job safely for all of humankind.
Allan?
Well, I'll start out by just a little bit of history. So I worked in radar systems, mostly for the U.S. government, but some commercial work as well for a couple of decades. And this is a LiDAR comment that I'll talk about more broadly, but LiDAR is sort of where radar was 30 years ago. 30 years ago, we both worked at Lincoln Labs, which is a big radar house. So 30 years ago, everybody was fixated on these little blips, little scan thingies. You might see them in sci-fi
Blobology?
movies. Blobology, yeah. And people were very, very into things like the power of the radar. That was a real
power aperture.
Power aperture.
The bigger is the better.
Bigger
Remember
is better.
that?
But no one cares about that anymore because it's all embedded into a larger system architecture. And I feel like that's true both of LiDAR and computer vision. Ultimately, you want to, price is important. The AutoX stuff was very, very impressive, by the way. The question really is how much of each sensor do you need? And to me, that's really the game.
So real quick, a note on what both of you guys are doing right now. Allan, what is AEye?
So AEye is a clever play on words, of course, AEye, but we work on mobility and transportation platform, safe autonomy for those systems with an emphasis on LiDAR computer vision fusion.
And you guys are very early in your life.
Correct.
Early enough that as a journalist I shouldn't ask you too many questions. We should go.
Correct.
All right, great. Then, Greg.
Currently, I'm working on, I'm the CTO at Humatics Corporation, where we've developed a very high precision radio microwave navigation system where we can navigate to about 500 micron spherical error probable. And we're releasing a product within the next 18 months. Fun times.
Similarly, not too many questions at this point.
No, not too many questions.
I want my car eventually, my self-driving car, to see as well as I do.
Yep.
Right now, there's no basket of technologies that's going to equal or be better than, which is really what we want human sight. How do we get closest to that?
You for one thing, you may never actually get that close. I mean, we know that most autonomous systems throughout history have always, especially when life or death is an issue, like the Apollo system, for example, like the Predator drones, like aircraft that have auto land capability. Human is always in the loop. But so it's going to be hard to ever beat the human, I think. But you're going to get different levels of autonomy, and those levels of autonomy must be extremely safe. And so, as I mentioned earlier, to get there, you will need all sensor platforms, including a phased array radar system like the Aegis Spy-1 that's used on the missile cruisers in the United States and our allies, including very low-cost LiDAR systems and optical systems. You have to have all those things. And I want to add that a prudent investor would probably make bets on each and every one of those technology categories. They'll all be needed for reliable autonomous vehicles.
So when you look at autonomous vehicles, we're at a sort of interesting inflection point in history. We've all spent our lives being very accustomed to trusting our lives with machines. But we trust it with the physical prowess of the machine, not with the cognition of the machine. Okay, so you step into your car and you have confidence the combustion chamber won't explode and so forth. But now with autonomous vehicles, you're relying on the machine's cognition, its savvy in how to avoid disasters. That's a fundamental and profound shift historically, and I'm sure historians are right about it for thousands of years if our race propagates for that long. So, what is the issue that I have with machine learning, machine vision with optics? We heard a talk earlier about deep learning. There's been a lot of discussions recently, some of it pioneered by MIT, about the obliqueness of deep learning in particular, but AI in general. So what I mean by obliqueness is that no one, not even the machine itself, has any clue as to why it did what it did. And an interesting question is, are we going to trust our lives to an entity that is incapable of articulating why it does what it does? And I think the answer is probably not. Now, it doesn't mean that AutoX or other kinds of computer vision things are not a good idea. They're a great idea. But you want to be able to probe the environment.
Stay with that 1 second, Allan. You think the answer is probably not. I mean, you can talk about that specifically when it comes to self-driving cars, or you can take a step back and talk about that generally when it comes to all of the artificial intelligence that will be infusing itself into the way that we do what we do in the future. How much do we need to understand what happens in that black box? And is our appetite for that going to change over the course of the next decade?
Well, I'd like to hear what you have to say too, but I'll kind of tee it up. So I like the analogy of medicine, because that's probably a great example where you're trusting your life literally to an individual, and typically we do things like get a second opinion. We typically will rely heavily on some type of specific measurement or assessment, experiment, test, whatever you want to call it, because we don't rely on the humans, the physician's intelligence. So I think that's a good model here.
Let's see. The question is how. Can you rephrase it? How do we have to know? We have to know how the black box works, or have confidence in the black box.
Well, do you need to know how the black box works in order to have confidence in that box?
It needs to be predictable. Simply predictable. As long as it's predictable and consistent, then the humans tend to be comfortable with it. There are examples,
which is different than it's a good idea for humans.
Right. They just have to be comfortable with it. It needs to be very predictable, like the autopilot on an aircraft or a boat. I know when I set my sailboat towards a certain course, it stays on it. Unless the wind kicks up too much, then it beeps at me and tells me I need help steering the boat. But as long as it's predictable, I think people will be okay with it. That's the key.
Okay. So one benefit to LiDAR is that not only is it predictable, but I can absolutely understand how it does what it does. And when challenged to computer vision as a supplement to LiDAR, or maybe LiDAR as a supplement to computer vision, is that I need to trust simply in its predictability without necessarily understanding over time how it works.
Well, here's the problem. For the computer vision versus LiDAR and also 3D radar systems.
Sure.
The 3D radar and LiDAR systems, they provide you a pixel at a range and an angle. And you know that that's where that pixel is, that's how bright it is, and including if it's a radar, that's the Doppler shift or velocity. You know what that is. With the optical systems, you have to make a prediction. And that's where the uncertainty comes in, is that you need to push it through either an AI algorithm or some other predictive algorithm to make an estimate of what that's actually doing. Whereas with a LiDAR and radar, it's intrinsic in the data that that pixel is over here and it's going this fast, no more processing needed. So that's where the reliability aspect comes in. That's what we mean by reliability. We know where that pixel is all the time, very reliably. Whereas with the optical systems, they're not making a guess, they're making an educated guess. Sometimes they're wrong. And the vehicles need to be safe to a very high margin. And is that the right thing or not? And we'll figure it out.
Yeah, we talk a lot about snapping to a grid.
Yes.
If you look at architects, building houses, contractors, you often see them with their little laser rangefinders, right?
Yes.
Now, an architect, it would be crazy for you to say, well, we're going to replace the architect with a rangefinder. It's just a fiducial. It's part of the overall task of figuring out how are things oriented.
Yes, that's right. They're involved, they know. But the coolest, I just want to come back to the fact that we know where the pixel is. There's no computational algorithm that must figure it out. It's just given to you. And that's the beauty of it.
So what needs to happen with LiDAR? I mean, you compared LiDAR to radar 30 years ago. What needs to happen to bring it to the place where it's going to be, where it's not going to cost $80,000 to put on the top of a car?
Well, there's a lot of clever folks that are looking into that, and we're looking at it as well. So I won't get into specifics, but I think that part of it is really thinking deeply about what do you need to do and how do you fuse it with the other systems and how do you complement the other systems. So don't do anything that you couldn't do with another system, and then figure out, okay, what's the capability that you need that's residual. I don't know if that's helpful or not.
I want to say only $80,000. That's what LiDARs cost now.
Oh, really?
Yes. So, all right. Here's the problem with radar right now. To put a phased array radar that can do something kind of like LiDAR in the car, that's probably $50 million unit right now.
Right.
Like, no shit. They're really expensive. I mean, it is. That's why they don't exist. Lots of smart people are working on them. It's a big problem. So LiDARs, in terms of at the short range, at the self-driving car range, at the industrial robot range, the LiDARs are winning the cost of goods game right now because there is no radar option that works that well. There are these little goofy proximity sensors and some other simple sensors that don't really do too much, but there's no phased array radar that gives you a voxel map like LiDAR yet. And if you were to do that right now, you're talking $50 million piece of equipment probably. But that's something that we're actually behind, and we need to work on that. And that's a problem I'm very interested in as well. It's doable.
Yeah, I would. I was very interested to see the previous speaker with the night vision by camera alone. The question becomes if you have someone wearing a black hoodie and black clothing and so forth that jumps out, what happens? And so that's an example where the fusion is very powerful because you can basically say, okay, I got to make sure there's nobody in this area. Let me probe that. Because with LiDAR, you're bringing your own light. You're not relying on the light that's already there.
Data fusion allows you, in other words, you can have a plurality of shitty sensors and a camera and use data fusion, and those crappy sensors become good, or good enough, hopefully. That's the beauty of data fusion. Everything will rely on data fusion for sure.
So I'm going to go back to my question. So with LiDAR, we're not there yet. I hear that we're behind. So what's it going to take? Do we have enough minds working on this? Is the industry demand strong enough? Is this a money issue?
Ask me in 6 months.
Well, you got Velodyne and whatever Allan's working on at least, and there's probably 10 more things out there. People are trying to get to that. And, LiDAR on a single chip that's 99 cents, perhaps, and a $100 cost of goods. The auto companies, they prefer a $25 cost of goods item. They're in a very slim profit margin industry. Yeah, it's coming along. But radar's way further behind. I can tell you about that. It's way further behind. We have much more to make up.
I want to bring the audience in just a second, so I want you guys to begin to prime your questions. But if I were to give you guys each 2 magic wishes for this industry, you can have 2 wishes granted in the next 12 months, but only 2, what would they be?
I'll take just
and
one
one
wish.
Cannot be for more wishes.
No, I got it.
Total
No. I'll go with one wish, and that would be a more sophisticated, informed customer among the OEMs. I think
among
that this is a difficult, challenging problem that's very foreign to everything the industry has done previously. And so it's hard to sell the correct answer.
What is today's customer need? Like what are they asking for? What do they think that they need?
I'm gonna.
We'll get
put
to you
my-
in a
I want to
put
second.
get to
mine
my
out already,
wish.
so-
I've got my wish ready. Can I say my wish?
Sure, go.
Okay.
Where's that NVIDIA guy? Is he here still? I've got a wish for you. Here's what it is. For radars, this is our biggest problem right now. We need causal computing, not more processors. We need wide bandwidth trigger lines going into your array of zillions of NVIDIA processors. If we can have that causal timing, then we can make cheap $80,000 LiDARs like these guys are, and then hopefully a few years from there, we'll have our $1,000 LiDAR and our $10 radar. Do you have any? You guys work on anything like that? I don't know. Okay,
He said
because that would be sweet. That is one of the biggest problems. That's why radar is so far behind LiDAR. We need to digitize radars. Short-range phase-rate radar, it's like an ultrasound probe. It actually operates by some similar principles. You're doing near-field data processing and making an image, okay, to get all those pixels. And what we need, we have a plurality of antenna elements, and we have to suck in lots of data per every element. We're talking like 100 megahertz up to a gigahertz of samples per second. And the only thing that can really swallow that data and do anything with it and take a bunch of cross Fourier transforms and stuff are the things you guys are making. So if we had that with triggers on it, and it was $100, we might like put the LiDAR people out of business. Just
Actually,
don't tell anyone though.
Alan, you want to
Work
change
on
your wish?
No, I don't want to change my wish. I wanted to amplify it a little bit, and this might be perhaps one of the more useful comments I make here today. So it's not so much just the O&Ms. We have a lot of different cultures here, which bring a lot of baggage, technical cultures, that they're not
Big
even
time.
aware of. And so so automotive guys, because I've done some consulting in the past when I was at Booz Allen Hamilton, chief scientist there for automotive companies, at both kind of high level, R&D, portfolio assessment, and product addressing product issues. And they're very focused. They're very, very used to real time, very used to actuators, control, and so forth. Then let's go over to the machine learning, cloud computing kinds of folks that hang out at LDV summits, vision summits. So these are folks that sort of are immersed in this concept that you just throw everything into the cloud, you just do lots of processing. They're used to the joy of pretty pictures.
Yeah.
Dr. I mean, fantastic stuff she showed, but I think
Yeah.
she'd agree. Those are pretty pictures. Those are two very different communities. Folks that deal with clouds and computer vision, they generally don't grasp the concept of, all right, how many microseconds do I have before death has occurred? What's the latest time of value? And that's really the disconnect in the cultures that I think is making progress very difficult.
That's a good point. Yeah. I'm trying to fix that problem, by the way. So, a few years back, I created this course at MIT called the Build a Radar course, where you build a radar out of coffee cans and wood and a handful of mini circuits parts.
Very
And a
cool.
laptop.
I sent some of my guys to that. Brandon Ayers, I don't know if you remember
Right
him.
on.
Yeah.
Right on. It's sweet.
Are you
Science.
are you the backyard SAR guy?
I'm the backyard SAR guy. I made
Yeah,
that.
this is really cool. This guy, the urban legend is it was a lawnmower,
It was a
that
garage door opener.
a garage door
Yes,
opener that
yes.
he converted.
A Genie. It's a
Wait,
8-foot long lead screw.
Yeah.
That you converted to.
Synthetic aperture radar,
A radar imaging system, just like the ones we want on in front of our cars, actually.
which
But
are
a
normally
mechanical
like
version.
like several multi-tens of $1 million systems, and you did it for like
$200.
$200.
Yeah,
Very impressive.
it's just some old trash and little know-how and stuff. But yeah, that's why the Coffee Can Radar course came about, because I thought, here's one problem about cultures. So I was at Lincoln Labs and starting to get sucked into the orbit of MIT campus. They do that. They suck you into stuff, and they're like, hey, why don't you teach a class on something cool and just do a class but make it interesting? I'm like, great. I've been building these radars in my backyard. Why doesn't everybody build a radar, and we'll image stuff around campus with it? So we made this radar, and every student built the radar out of wooden coffee cans and stuff, and they imaged stuff around MIT campus. Whoever had the best image got a prize. But what we were trying to do is change the culture at MIT, which is you've got Media Lab, you've got all these cool things. People are putting papers in. Someone mentioned SIGGRAPH. I've had 1 or 2 papers in SIGGRAPH. They're doing really cool shit over there. And so over the past what was it, 6 years now when we started that course. Last time I was at Media Lab, I saw coffee can radar stuffed into people's desks and all over the place, and we had CSE grads and math people, and you're playing with coffee can radars for the first time. So we're trying to crack that now. It's a tough one to crack, but there is a huge cultural difference. You couldn't be more correct about that, Allan.
Yeah, and I do think going back to the coffee can radar or the lawnmower radar, whatever you want to call it, that the advanced processing that we have today allows you to deal with pretty crappy systems, and you clean them up digitally. And that's a fun thing to do.
Our
so
data
anybody
was so
out there who's got
shitty.
ideas like that, I really appreciate it.
We had the worst data coming out of those things.
He's proud of that, guys.
It was awesome. You're exactly right.
Well, let's get the audience in here. Do we have any questions in the audience?
Yeah,
Okay, and if you can give us your name before you ask.
Ashur Beg with Huawei Technologies. I have a question about the black box concept that you mentioned, the ability to go back into the black box and dissect and find out the rationale for the decision that the machine made. Was it, killing an 85-year-old person versus a 9-year-old boy? The choices the AI brain made. I think that concept would be very valuable to the insurance industry, because the self-driving cars is going to lower the insurance rates by 30%. But if you don't have the ability to go into the machine and say why you made that decision, and it's just a black box, and you just rely on the rationale that it's just going to make a logical decision, it has implications on the litigation aspect following an
Great
question. I agree with that. I think that's a great point. I was tempted to say something about that, but it's a rather morbid subject. No,
Let's hear it,
pun
man.
intended. But black boxes. Okay, so the ability to determine what happened during an accident or collision. I predict, and I'd be willing to bet money on this if anyone wants to. Not money, beer. That's more civilized.
Oh, yeah.
Or a margarita would work too. That once we get laws passed, there'll be a mandate for a different kind of black box. Not meaning a black box meaning you don't understand it, but a thingy that if there's an accident, you can go pull out data and figure out what happened. And I tell you, that's going to have to be something, in my opinion, that's either LiDAR or radar, because that's the only way you can say, I was here, they were there, and that's it. And no one's going to argue with me.
Greg, do you agree?
Yeah, but I thought, just to be clear in your question, are you talking about like a black box where the goes into and goes out makes a decision that says, I want to hit the 80-year-old versus the... Ooh, I have no answer for that yet. That's above our pay grade. That's a rough one. I think everyone in this room has an opinion on that, because if we're dealing with that technology, we're going to have to put laws and regulations in place to kind of outline what those decision matrices are, I'm sure, at some point, and that's going to be interesting.
Okay, yeah, that's a different question. I'm sorry. My view is we're probably not going to have that. I think that's an interesting theoretical debate, but I think we're going to have to get to a safety level that we're not deciding who to kill. I think we're going to have to do much better than that.
Yeah.
Well, let's just stay on that debate, which is a debate that you can't not talk about when you're talking about this technology becoming commercialized. But you can talk about who gets to make the decisions around that. And you talk about an educated customer, now you're talking about the OEM. But one step beyond that, are those kinds of decisions going to ultimately be made by consumers? Like when I buy my car, am I going to get a sort of a multiple choice ethics test on the way in that's going to help me be the one to make those decisions? Oh, Greg, don't make that face.
I don't know. You know what? This is why the rollout of these things is going to be complicated for our society. No one knows what the answer is. We've had a couple of deaths, which aren't too many yet, but there's going to be more. And many states, autonomous driving vehicles are actually outlawed. The state of Connecticut, they're completely outlawed, by the way, and many others. Most of the vehicles are driving in California, where the weather's nice, and they should be driving in Michigan, where we have snow, sleet, and rain, and everything else. So. Those are some crazy philosophical questions. But I think if we do our jobs right and we provide high reliability LiDARs, radars, precision radio nav, and combined with the incredible advancements in optics, the optics people are way ahead of us, as Professor X has shown us. We'll get to a product that's going to be pretty safe, and hopefully it'll have the data it needs to plow into the right pedestrian if need be, which
Yeah.
maybe they'll run into a truck instead that can absorb it or something like that.
Well, this does, it's an interesting question because it raises the scalability of autonomy. So essentially, one level of autonomy is, you get in your car and you tell you want to go from here to there, and it does it. The other one is an autonomy where you anticipate moral decisions being made by the machine.
Mm-hmm.
So when we talk about this, I'm assuming that you're going to educate this machine as to the value of different lives. And quite frankly, as humans, I don't think a human is really well equipped to make triage decisions in terms of which life to take or not to take. And I think most of our moral codes are that we're very limited in our moral blessing to do that. So you're really sort of taking autonomy at the cusp of the most difficult decision a human being could ever make, most difficult moral decision, and we're a long ways off. I respect the question. It's an important question. I just think it's sort of at the very top of the scale of how much autonomy you're giving away.
All right, any other questions out there?
Yeah, this is particularly directed towards Allan because of your experience working on...
and can we get your name and affiliation?
Oh, sorry, yeah, I'm Paul DeConcoli-Tega. I work for a startup company called Numina. I ask this question in particular because of some of the dynamics of commercializing sensor technologies associated with, DoD R&D investments.
Mm-hmm.
And we've talked a lot about this Velodyne sensor being the state of the art and yet still costing $80,000. So can you speak to some of your vision of the whether it's a more meritocratic arrangement to have some of these sensors invested primarily from the commercial side, and whether or not you see that actually advancing the affordability of those sensors more efficiently than DoD investment, or the other way around, seeing as it's kind of the state of the world now that commercial R&D is far outpacing defense R&D.
Yeah, that's a great question. Give me about 6 hours, and I think I'll completely have... No, seriously, I mean, I consulted at Booz Allen for both commercial and government. It's a very big, complex problem, although I will tell you, and this is what we're doing at AEye, but a lot of companies, it's hard to mix the two. And I would say that there are many, many areas where the commercial is light years ahead. And typically, the government does well when there's a technology that really only is useful for the government. So if you want to do simulation of ocean wave impacts on large ships in hurricane gale forces, yeah, the government's best in the world. But as more and more sensing becomes commoditized, I think it gets away from the government's hands and it becomes more of a commercial play. That's my opinion.
I think the government technology, of course I'm coming from the radar side, is just light years ahead of what's going on in the commercial sector. They throw lots of bodies at it. They throw lots of money at it. They're willing to have two major defense contractors do the same thing at once, and may the best man win. And the reason for that, it's about the survival of nation states, which hopefully 1,000 years from now will seem like a crude thing, that we actually fight over stuff and kill each other over principles, but it's still that way today in this century, and that's why we spend the big money we do, and we get amazing tech out of it. Although they are on massive timescales. They're doing massive things, or on massive timescales. There's a lot of people involved. Probably the fastest government program in history was the Apollo program, and probably the slowest is, I don't know, we've seen a few that are probably pretty slow. Yeah. But they all get something at the end that's really
That's true
crazy.
For monolithic. So there's been a big debate in the government. I've been sort of part of it, and if you're tracking DARPA's focus on swarms and so forth, there's a school of thought, which I'm all in on this one, that crowdsourcing, swarming, ubiquity of low-cost things, say the IoT, that ultimately has the ability to supplant, in the vast majority of cases, these large Battlestar Galactica radar systems and so forth. So
Predator. They always look at it like
right.
Predator.
So basically, if the Internet of Things is the future of civilian technology, it's also the future for defense.
Well, there's a good case study with when I say Predator, I don't mean the movie Predator with Arnold Schwarzenegger. That was
a little thing
cool.
that flies around.
The thing that flies around. So the Predator drone costs a mere $4 million. They're probably up to 10 these days. It has a couple of Hellfire missiles. There's a Predator 2. It's got 4 Hellfire missiles on it. The ratio of Predator flights to F-16 flights in the War on Terror is probably 100 plus to 1. I forget what. It's very high. They always fly. They just fly Predators all the time. And that's to DoD, the Predator, $4 million, that's cheap. That's Internet of Things for them. And it's been a wildly successful program.
Yeah, I also think the timeline of the technology, the technology S-curve is important. Obviously, VCs and the commercial sector aren't going to be looking at a 10-year lifespan.
Yeah, or
I
less.
think my personal view, and I could be proven wrong, but for example, quantum computing, I think it's a really bad idea for VCs to invest in that right now. It's a great future, but it's not the time. I think things like that. That's where the government or governments internationally really thrive.
Every time I see quantum computing, they show me the picture of a die, and they're like, here are these 3 or 4 qubits or some number of qubits. But they don't show me the 10 racks of microwave shit in the background, pinging those things and getting the electron spins out and stuff. So it's pretty far from useful, yeah.
Okay, one more question.
Yeah.
And if you could give us your name first.
Yeah, my name is Cherry Tom. I'm from IEEE, and I have a systems question. I had a talk a few years back about the whole issue of autonomous cars, actually creating more traffic problems. And also taking up too much space, parking lots, garages, etc. I don't know whether you work with government agencies and stuff like that to work the system problems.
Well, I've read a couple of books on the topic. I've never heard anybody argue that there's more congestion. There might be if one guy is driving an autonomous car and has to have a whole lane, blocked off. But there's been a lot of interesting studies. New York City, we're in New York City here, okay? Imagine if everybody drove into New York City instead of having taxis. You'd be completely hosed. It's bad enough as it is.
Yeah.
So there's been a lot of people that have done studies on New York City and on the number of people that move around on taxis, and they extrapolate backwards to what if we had self-driving cars? The car goes into the city, drops you off, services 10 other people, 100 other people, factor of 30 to 100 reduction in congestion. No parking lots, no garages or gas stations, because the cars just drive off in the middle of nowhere to get serviced, and they're like a horse. You whistle when you need the horse to come. So I think there's a tremendous body of evidence that's been done by third-party, unbiased individuals that would argue quite the opposite.
Yeah, I agree.
Okay, we got time for one more question. Any out there? All right, then I'm going to come back and just ask you. A while ago, when we were talking about your first wish, you said that you wished that OEMs were smarter in knowing what they're looking to buy. What are they missing that they need to be smarter about?
I think it's. I mean, I've been in the government, and whether you're a government or a large prime contractor, and this may not satisfy you because it's a little technical and a little philosophical, but maybe it will. Depends on your mood.
Hey, don't underestimate me.
But no, I'm not underestimating you. But the ability to differentiate a requirement from a solution. So a lot of times, like an OEM might say, "Oh, LiDAR, I need to get a point cloud, dense point cloud uniformly everywhere. That's what I need." The question really is, why do you need a LiDAR in the first place? What is it that you're missing? And what if you let people figure out how to address what you need, not what you think you want, because you've already come up with your own solution in your head. And that's a very subtle issue, because a lot of times, we talk about this at DARPA all the time, that guys who are DARPA chief scientists, we used to say, hey, we don't address requirements. Mm-hmm. It's very hard for a customer who doesn't know the art of the possible to ask for what they need. They usually come up with a solution, say, can you build me X?
That's the faster horse conundrum.
Exactly.
Well,
I love it. Faster horse. Thank you.
I think the OEMs are very smart. I think we can
They're
take...
smart, no question.
I think they get it. I think that the shakeup at Ford Motor Company earlier this week is an example of they totally understand where things are going and where they want to be. In my experience in engaging the OEMs, I've found that they've been pretty sharp. They got the $10,000 Velodyne thing. They got the $1 million radar thing. And if you show I could do that for this much, you'll get their attention. They know how to use that stuff.
So we're going to pick up this conversation all day, and so we'll end it here now. Thank you very much, you guys.
Thank you.
Thank you.